Computers are dumb machines. That might seem a surprising message in a class that's supposed to inspire you to work with computers, but it's true. At the end of the day, they're just a bunch of switches that have been wired together in an extremely clever way. Computers don't think, but they can process information very, very, very quickly. Hey Siri, what's the first prime number above 10,000?
First prime number is 10,007.
Siri is able to provide that answer so quickly because of its ability to engage in a repetitive process at a mind-bogglingly fast pace. Repetition is the key to many sophisticated programming challenges. Today, we're going to learn how computers use repeating code to solve problems. By the end of this lesson, you should know what a loop is and how a computer implements loops, know the syntax of a while loop, be able to use a while loop to solve a variety of problems. Repetition is a process that we are familiar with from our day-to-day life. For example, when you go to the grocery store, you might have a list with you of all the things that you need to buy. As you acquire each item, you cross it off the list. How do you know when you're done? When you have no more items on your list. Here's the same logic represented as pseudocode. While there are items on my list, get the next item on the list, cross the item off the list. We indent these two instructions because they're dependent on the condition above being true. Are there more items on the list? It's a Boolean condition. Either it's true or it's false. The logic expressed in the pseudocode can be easily transformed into what is known a while loop. Here's the basic form. Notice the similarity to the if statement. It's got a Boolean condition in parentheses after the keyword while. The only difference is the while loop will repeat again and again as long as the condition remains true. An if statement executes one time when the condition is true. The while loop will execute once, then jump back to the condition. If it's true, we execute the statement again and again and again. If you're smart, you've probably already made an important observation. If the condition is true at the outset, then it's going to continue to be true. That is, it will continue to be true unless something happens in the block of code that changes it. If we don't have something that changes the condition, then the loop will execute again and again. That is, it will continue to be true unless something happens in the block of code that changes it. If we don't have something that changes the condition, then the loop will always be true. So we'll continue to execute this code again and again, on to infinity. That's what's called an infinite loop. We'll talk more about that later. For now, suffice it to say, it's something we want to avoid. Here's our first example of a while loop in Java. Let's look at the code and make a prediction about what it will do. It's a liftoff program. It counts down from 10 to 1 and then the word liftoff. It doesn't show the image of the Falcon Heavy. Someday we'll be able to do that. Quick question. What would happen if we got rid of the statement that said x equals x minus 1? When we eliminate the x equals x minus 1 statement, we remove the means by which the condition can change. This puts us in the dreaded infinite loop. The value 10 prints again and again and again forever. Now you try. On the next screen, write a method that will count to 100. You may recall that we did something like this already. We wrote a method that would count to 10 by writing out 10 print line statements. This time, use a loop, and you should only have one print line statement in a solution. Note that you'll be asked to write a main method and a count to 100 method, and that you will call count to 100 from main. Go ahead and give it a shot. Press continue.